Arild Gustavsen is a professor in building physics and director of the Research Center on Zero Emission Neighbourhoods in Smart Cities at the NTNU, Norway. And he will tell us more about the concept of zero emission buildings with some examples and also with some challenges. So go ahead.
Thank you very much. And thank you for this invitation to come here and present some of our work. Yes, my name is Arild Gustavsen. I'm a professor at Norwegian University of Science and Technology in Trondheim, Norway. And as said, I will tell you a bit about the zero-emission buildings and also zero-emission neighborhoods. These are big research activities in our university, and this is also work we do together with Norwegian partners. I'll get back to that in a bit. So first I will give some background. Always have one or two slides on the background before I get more into zero-emission buildings and zero-emission neighborhoods. This background most of you know, of course. Why do we work with the zero-emission buildings? Energy use in the European building stock amounts to about 40% of the energy use, or to 40%, and 35% of the greenhouse gas emissions. We see some different numbers now and then, but it's close to this. And another number that is important when you look at buildings and construction industry is that about 50% of the extracted materials are attributed to this sector. So the conclusion then is we need to look at more sustainable ways to develop and transform and make buildings. If you look at the energy use in Norway for the building stock, we see that the average is around 200 kilowatt hours per square meter per year. And there has been a gradual increase in the requirement. So in 2010 it was reduced to below 150, and in 2017 it was reduced to close to 100 kilowatt hours per square meter per year. And if you look forward, I think we can assume something like this. In 2020, nearly zero energy, although this could also be defined differently. And also 2025, maybe zero energy. However, in Norway, the last 8-9 years, we have been working on the zero-emission building concept. And then the objective has been to develop competitive products and solutions for existing and new buildings that will lead to market penetration of buildings with zero greenhouse gas emissions related to their production, operation, and demolition. So we look at the whole life cycle of the buildings in this center, and this is also an innovation center where we work closely with the building industry. Then a couple of years ago, we also started another initiative looking at the interaction between the buildings and also including the energy companies in our research. Then we also include the municipalities and also ICT companies doing this research. So it's a lot of the collaboration going on. Then back to a zero-emission building. What is that? And during the first time of our research center, the previous one, we made preliminary definitions of a zero-emission building, which we refined and further developed throughout the 8 years. And a lot of the work was done together with the partners when they realized or built real buildings together with them. So we tested the definitions and saw what was possible. But the ultimate aim is to have a new renewable energy production on the building or near the building that should compensate for the emissions related to the materials used during the life cycle of the building, the construction phase, and also the use phase, and also taking into account the demolition phase. So to be a full zero-emission building, you need to have the renewable energy production should be larger than the sum of these. Another interesting topic here, or a note, is that the emissions related to the materials is almost the same size or even more than related to the use phase of the building. So working on the life cycle and working on the materials, finding environmental solutions is just as important as having an energy efficient building. But we also see that this is a very ambitious target, and because of that we have made some alternative ambition levels where we have less renewable energy produced on the building or on the building site. So this one we call a zero emission building in operation, because the size of these two is about the same. And then if we increase the amount of renewable energy, we can have maybe renewable energy to compensate for the operation and the materials. So then it's the zero emission buildings with operational materials, SEB OM, operation materials. And we can also go further to increase it even more. So we have worked with companies and built buildings that follow these ambition levels and this calculation procedure up to what we call SEB, zero emission buildings, compensating for construction, operation and materials. And what we see is that this promotes several things. It promotes reduction of greenhouse gas emissions. It promotes energy efficient buildings, reducing the energy use and emissions related to use phase. It promotes new local renewable energy and also reduction of material use. If you reduce the amount of materials, you reduce emissions. And it also promotes the use of more environmental friendly material as well. And also optimization of energy flow. And this is the different ambition levels tested on the different pilot buildings. So starting with SEB O minus equipment, where we subtract the plug loads that vary from building to building, up to SEB operation, and all the way up to SEB COME, taking into account construction, operation, materials, and end of life, which is the most ambitious level. Just some examples. This is one pilot project from close to Oslo in Sandvika. It was an office building and a renovation project built in the 1980s. And what they did here, they aimed for this SEB operation and materials. We took out the plug loads. And they reused the concrete structure, which of course makes sense. They also reused a lot of the external glass materials in internal walls. Also used quite a lot of wood in the facade, a combination of natural and mechanical ventilation system, and also a lot of PV photovoltaics, solar panels on the roof of this building, as well as on a garage nearby. Looking at the energy use of this building, you can compare it to what it would have been if you built it according to the standard at the time, Technical Regulation 2010. It would have been slightly below 150 kilowatt hours per square meter per year. Here it's a total different picture. And we also take into account the energy used for material production. Another building, residential building, demonstration home in Levesque, even further south of Oslo. And here the architect is Snøta, as it also was in the previous building. For this building, they aim for the SEB, operation and materials ambition level. This is a new building, new dwelling. And they also still try to reduce the material use and also reuse other materials. They also combine different systems like a heat pump, photovoltaics, and solar collectors. Just an example what we can do with the material emissions if you think or address this in more detail. The original plan for this building was to have a concrete core, a concrete wall, to introduce thermal mass to the building, to level out the temperature fluctuations. But looking at this concrete, it would contribute quite a lot to the carbon emissions from the materials. So that's why they looked at other alternatives, shown here, regular concrete. They looked at low carbon concrete, but they ended up with using bricks from a farmhouse that was taken down in quite nearby. And by doing this, they were able to reduce the carbon emissions quite a lot from this system. And then you need to do this kind of analysis for the whole house, trying to look at different alternatives. And looking at the energy use again, comparing to tech, I think this should also be the technical regulation at 2010, which was valid at the time of this building was when this building was built. Again, we see that energy use for operation is reduced quite a lot, working a lot with energy efficiency and energy efficient technologies. And again, we include look at energy use for material operation, and also we have a lot of focus on renewable energy production for this building. And when you look at the material emission, this is taking into account that you have to replace materials during a 60-year lifetime. Assume a 60-year lifetime of the building, and then you divide that by 60 years, and you get this number. Okay, then a bit more on our recent work on zero-emission neighborhoods in smart cities. And I've seen a lot also, seen some information about the MODER project, and I think there is some similarities between these activities. So here we stop to look at individual buildings. We still have to work with individual buildings, but they will be they will be elements in the energy system. And then use energy and also contribute with energy if that is possible. But to address this topic, we have divided the work in 6 work packages. In work package 1, we are looking at the development of an analytical framework for design and planning of zero-emission neighborhoods. Also looking at policy measures, innovation and business models. And work package 3, 4, and 5 are looking more on the technological side of development of a zero-emission neighborhood. And then work package 3 is on the responsive and energy-efficient buildings. Work package 4 are looking at interaction between the buildings, how one energy can use energy from the neighboring building, for instance. And work package 5 is looking at the optimization between the neighborhoods and the larger energy system, and analyzing if it's makes more sense to invest in local sources versus more centralized sources, or like windmills on the Norwegian coast, for instance. And in work package 6, we also have, like in the previous center, the SEB center, we have a lot of pilot projects and working with our partners in this. So how do we define neighborhood? And then a zero-emission neighborhood. So this is something we recently has worked a bit on. And it is written here, a neighborhood is defined as a group of interconnected buildings with associated infrastructure located within a confined geographical area. So then we start to take into account also the infrastructure between the building, and would like to compensate for the emissions, or at least address the emissions related to this and reduce the emissions. And as it's written here, the buildings will then can be new buildings, existing buildings, or usually a combination of this. And we look at the exchange of energy, generation of energy, storage of energy inside the neighborhood, and also interaction with the surrounding energy system, and also include the grids and technologies for water, sewage, waste, mobility, and ICT. And specifically, we address 7 different areas that will be broken down to KPIs, but I will just show these areas now. So we have to plan, design, and operate the buildings and associated infrastructure components towards zero life cycle greenhouse gas emissions. So we still look at the life cycle of this system and then addressing using 60 years for building and 100 years for the infrastructure, which is common according to international standards. So greenhouse gas emissions is still on the top. In addition, we'll look at energy efficiency for the buildings and the associated technologies, and also installation of new renewable energy in the area. Further, we need to manage energy flow in an interaction with the surrounding energy system in a smart and flexible way. So then looking at how these neighborhoods and the buildings can be an active element and reduce the strain on the grid. And also to promote sustainable transport patterns and smart mobility. So also looking at, for instance, how electrical vehicle can be a resource in this neighborhood energy system. Further, we need to plan, design, and operate with respect to economic sustainability and by minimizing total life cycle costs and life cycle system costs. We have partners, industry partners that focus a lot of this on this aspect. We also discuss how the cost in technologies in the local system should be compared to the total system cost. So this is also an important research question. We also have to plan and locate amenities in the neighborhood to provide good spatial qualities and to stimulate sustainable behavior. So starting to also include the users and the citizens in the planning is important. And then also to look at innovative solutions. Both these centers, this Zero Emission Building Research Center and the Research Center on Zero Emission Neighborhoods, is part of a funding scheme by the Norwegian Research Council that promotes or should result in innovation. So this is the reason for the last point. Then we have, as I said, some pilot projects. And we are working with municipalities, energy companies, building developers, building owners in 9 different pilots. The pilots are located from Bodø in the north to Bærum in the south. Bærum is close to Oslo. And they have allocated 9 areas that we should look at and work on. So this also work as innovation hubs and inspiration for other partners in the project. And we have about 30,000 people involved in these areas, and also a floor area of more than 1 million square meter. And this is different kinds of areas that we have selected based on different criteria. There are some new developments from the start. For instance, Zero Village Bergen is a totally new development with a private partner. We have also a combination of new and existing buildings that needs to be developed. For instance, Sluppen and Furuset in Oslo, where we also consider social aspects of the developments. In Bodø, they are actually moving an airport and want to free up space for future city developments because of this. And yeah, so it's a mixture of different kinds of developments that we address. Then finally, 2 slides on the challenges and the possibilities. There are, of course, quite a lot of challenges when working with buildings, but when you start to address many buildings, you get a new set of challenges. And it's written here, building services and infrastructure users, owners, and developers will probably not have the same ambition level related to emissions. It might be a lot of different wishes related to how to develop the area, and this might be a challenge, of course, in reducing the carbon emissions for a city or for a neighborhood. And also, if you're going to exchange energy between the buildings, at least thermal energy, you would like to have a district heating system in place. This is not usually the case always. There are also regulatory barriers for exchange of energy, especially between end users, and that's at least it's like that in Norway. And also there's a need for technical and legal standardization enabled to make this happen, especially when you use different technologies. And also on the tool side, I think, of course, a lot is happening these days with moving to the districts and areas when you plan for the future. But still, there is still a lack of, especially emission data, connecting to infrastructure and also for a lot of building materials and products. But also some possibilities, of course, and. What we think is that optimization on the energy use and renewable energy production should be easier and make more sense when we address a larger system than when we address individual buildings. That's one of the main motivations for doing this zero-emission neighborhood center. And also focusing on the neighborhood instead of individual buildings, you get also to tackle the infrastructure between the buildings and supporting the buildings. This is also important to try to look for alternative solutions and more low-carbon technologies. And also installation of new renewable energy technologies can be easier when addressing an area instead of individual buildings. And also neighborhoods are more suitable for implementing integrated and innovative solutions in direct connection with citizens. And then I think it's compared to the larger city. It's easier to engage with citizens on a smaller scale. And then also the main aim behind this is also to speed up the decarbonization of the building stock. And I think that is easier and could be done quicker if you address several buildings instead of individual buildings. So that was the last slide. Thank you.
Thank you so much, Arild. Time for some questions, comments from the audience.
Thank you for the interesting presentation. I have a question about the how do you meet those who need demolition material for their new projects and those who are planning those projects?
It's not a well-developed system yet to find used materials. It is not. There are some initiatives around, but it's not national-wide. It's mostly local. And you need to know about the specific projects, I think, in many cases to make this work. But I think that this should be developed further. It's a market potential, I think, especially when you try to, or when you start to focus more on also the embodied emissions related to the materials, which I think we should do.
You seem to have quite many interesting pilot projects. Which are the incentives for developing those, and what's the motivation for those pilots to join?
A lot of the pilot project is most of them are pushed forward by the municipalities that has set ambitious greenhouse gas emissions goals for the cities. So they want to be part of this to learn what is possible, so I think most of them are based on that. But you also have one private developer that wanted to go forward and to also show what is possible to prove themselves as an actor in this green economy, I think. So far it's mostly municipalities and companies taking a stand to show what they are able to do, I think. But of course you need business models to make this adapt into for the regular users also. But this is not the case at the moment. Yeah, I think it's...
Irma Karala from HSY. Thank you for presentation. I would like to ask, is this program connected to the Future Build program which was financed by the Norwegian ministry?
Yes, some of the pilot, or one of the pilot projects in the SEN Center is connected to the Future Build program, and Future Build is a partner in the SEN Center, so we work with them. Yeah.
One more question. I would like to hear your opinion about the Nordic. I think it is the Norway's highest wooden building, and maybe also the highest wooden building in whole Scandinavia, which is going to be built in Norway, in Brumunddal, from my mind, in the middle of nowhere. So what do you comment about that case?
Yeah, a bit skeptic, maybe. Because the transport is an important topic when we are addressing climate change, of course, and putting a building in the middle of nowhere might not make sense in that regard. But there are always many reasons for building or setting up a building. So it might be other arguments that weigh more. But I'm not sure. I don't know the project in detail myself. Yeah.
Thank you so much, Arild. You will also join us in the panel discussion after the coffee break. So, so we will also then continue the discussion over there. Thank you once more.
Okay. Thank you.